Good day, students. In this clip, we're going to go over how to find the product and quotient of complex numbers in polar form. Okay, so right now the title of the notes, finding the product and quotient. Quotient, this means divide of complex numbers. Complex numbers in polar form. So that's the title of today's notes. Alright, we're going to start with product and then we'll do quotient after that. Alright, so let's start with product of complex numbers. Alright, we're going to look at the formula first, and then we'll go into how the formula came about. Alright? Alright, so the formula for the product of complex numbers is we have the first complex number r1 indexed by 1, r1 of cosine theta 1 plus I sine theta 2, sine theta 1. This is the first complex number multiplied by another complex number indexed by 2, r2 cosine theta 2 plus I sine theta 2. If we have a two complex numbers being multiplied like this, the formula is going to be, this is going to equal the product of the absolute values, r1 times r2 times the cosine of the sum of the angles theta 1 plus theta 2 plus I sine the sum of the angles theta 1 plus theta 2. So whenever you're multiplying complex numbers, all you just have to do is multiply the r's and add the angles, and that's basically that. Take the cosine and the sine of the sum of the angles, and that's basically that. Okay. All right. Now we're going to derive this formula. How did this formula come about? So let's write a proof or a derivation. Let's call this derivation. All right, we're going to derive this formula, the product of complex numbers. Alright, so let's do the derivation. So for this one, we're starting with two complex numbers, r1 cosine theta 1 plus I sine theta 1, and then we're going to multiply by the second one indexed by r cosine theta 2 plus I sine theta 2. Now the goal is to get this result right here. Let's see if we can get it. So what we'll do first is we just we can take r1 and r2, factor them out, and then we can distribute these cosine and the sine. So basically we can have r1 and r2 on the outside, bring them out, so they're products, and then we're going to be multiplying cosine theta 1 plus I sine theta 1 times cosine theta 2 plus I sine theta 2. Alright, so this inner component here, we're going to distribute or FOIL it out all the way. Alright, so we're going to do first outer, inner, and then last. So what does that generate? Let's see. Bring down r1, r2, we're done with those. We're not going to touch it anymore. And then inside we're going to have first and first cosine theta 1, cosine theta 1, cosine theta 2, sorry. First outer is going to be plus, write the I first. Let's do sine theta 2 cosine theta 1. And then we do the first outer, and then we're going to do the inner, which is going to be plus I sine theta 1 cosine theta 2. So that's the first outer, and then we just did the inner, and then the last is going to be plus, put it down here, I times I is I square, sine theta 1 sine theta 2. Okay? Alright, now I'm going to bring down R1, R2. Cosine theta, let's do, the cosine theta 1 and the cosine theta 2, and then the sine theta 1 and sine theta 2. Now, we'll bring this one down, cosine theta 1, cosine theta 2. Now, wait a minute, what is I squared? Remember, I squared is negative 1, right? I squared equals negative 1. So this I squared is going to change this to a minus. So, and we're going to bring it to this one right here. So it's going to be minus sine theta 1 sine theta 2. Okay? And then these two pieces right here, they both have i's in front of them. So I can do plus, factor out the I, and then we're going to have sine theta 2 cosine theta 1 plus sine theta 1 cosine theta 2. Like that. Okay? Now we're going to think back to identities. We have cosine, cosine, sine, sine with a minus at the center. What on earth is that? Think back to identities. So we have cosine, cosine, sine, sine with a minus, that's cosine alpha plus beta. And then we have sine, cosine, cosine, and sine, that's sine alpha plus beta. Okay? So this piece right here, this first part is simply the sum identities for cosine. So it's going to be R1, R2, R1, R2, of cosine theta 1 plus theta 2. Okay? And then plus I times sine. And this one right here, this is the sum identities of sine. This can be written as sine theta 2 plus cosine theta 2, but the order doesn't really matter, right? So I'm going to write it as sine theta 1 plus theta 2. Remember, theta 2 plus theta 1 is the same thing as theta 1 plus theta 2. Okay, so I just switched this around, but this is the sum of the angles, right? Addition is symmetric, so it doesn't matter which order I put it. So theta 1 plus theta 2 or theta 2 plus theta 1. It doesn't make any difference. Alright? So this is exactly what we want. The product is the product of the radii times the cosine of the sum plus I sine of the sum of the angles. Alright? So this is the formula we're going to be using for the product component of our classwork. Alright, so let's try an example. Example 1. Find Find 3 cosine pi over 4. Wait a minute, I can write it as well. Cosine pi over 4 plus I sine pi over 4 multiplied by 2 cosine pi over 6 plus I sine pi over 6 and express your answer. Express your answer in rectangular form. Rectangular form. Okay? So there you have it. Alright, let's try this out. So we know that this is R1, R2, theta 1, theta 1, theta 1, theta 2, theta 2. Okay, so the first ones are the ones, the second one are the two. So we're going to apply the formula. So the formula says we multiply the radii and simply add the angles. Okay, so this is R1, R2. It's going to become 3 times 2 on the outside. Alright, R1, R2 times cosine. You add the angles. Pi over 4 plus pi over 6 for the cosine part, plus I sine pi, the same thing, pi over 4 plus pi over 6. Alright? Now, what is pi over 4 plus pi over 6? Let me do it on the side here so I can save spaces. Pi over 4 plus pi over 6. The LCD of 4 and 6 is 12, right? So I need these denominators to be 12. So I times this by 3, top and bottom. Times this by 2, top and bottom. So this becomes 3 pi over 12 plus 2 pi over 12. When I add both of them, I get 5 pi over 12. So this is your sum of the angles, okay? If you don't like radians, you can change this into degrees and that'll be much easier. Same thing, okay? So we're going to have 6 cosine 5 pi over 12 plus I sine 5 pi over 12. Alright? Let's work this out. What is 5 pi over 12 on your unit circle? On the unit circle, 5 pi over 12 is... Alright, so 5 pi over 12 is not on the unit circle, so we just have to use our calculator to finish this one out, okay? So, let's see. Back to the original question. So this is our answer. This is our answer in polar form, okay? So answer in polar form. But the question asks for the answer in rectangular form. Alright, so how do we express this in rectangular form? All we just have to do is plug this in our calculator. Alright, what is cosine 5 pi over 12 and sine pi over 12? So, fire up your calculators. Make sure you're in the right mode. The right mode. Cosine 5 pi over 12. Enter is 0.9997. And then sine 5 pi over 12. Is 0.22228. Alright, so it's going to be 6 times 0.9997 plus 0.228, I think. 0.0228 pi. 0.0228 pi. 0.0228 pi. And then you just multiply both of them by 6, and that'll be your final answer. So, let's do that. So 6 times 0.9997. Let's be lazy, I can do both of them together. Plus 0.0228, plus 6 times 0.0228. You have an I right here, period, like that, okay? Enter, and it gives you your answer. So your answer is going to be 0.59982. So when you distribute, this to this is going to be 0.59982 plus, and then when you distribute 6 to this one right here, you're going to get 0.1368. Okay, this one is 5 point. We're changing stuff around. 5 point, and then this one is 0.36, 0.136, 0.1368. 0.1368. Alright, so there goes your final answer in rectangular form. Alright, so that's that. Alright, now we're going to work on, take a look at quotient of complex numbers in polar form, okay? Alright, write down the subheading. Quotient of numbers, quotient of complex numbers in polar form. Quotient of complex numbers in polar form. Okay? Alright, first of all, we're going to write down the formula, the derivation, and then look at an example. Alright, so the formula basically is you have the quotient of two complex numbers in polar form, r1 cosine theta 1 plus I sine theta 1 divided by r2 cosine theta 2 plus I sine theta 2. These are the two complex numbers. If you have that, what do you do? All you simply do is you divide the absolute values of the radius, r1 divided by r2, times, remember for product we added the angles. In this case, you're going to subtract cosine of the difference, theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Oh gosh, I messed up my parentheses. Theta 1 minus theta 2 in that order. Okay? Alright, so how did this formula come about? Let's derive this formula. Derivation, see if we can derive it just as we did with the other one. Derivation. We're going to start with the left side and see if we can end up with the right side, okay? Alright, so let's say we had two complex numbers we're taking the quotient of. So let's say we had r1 cosine theta 1 plus I sine theta 1 divided by r2 cosine theta 2 plus I sine theta 2. Let's say we have something like this. Now, how do we find, let's simplify it. We want to find the quotient. So let's see. If I look at my target, it has no denominator, so I need to clear out this denominator. Alright, so I'm going to multiply by something that will reduce this into 1, okay? I'm going to times the numerator and the denominator by cosine theta 2 minus I sine theta 2. Top and on the bottom, cosine theta 2 minus I sine theta 2. Alright? Okay, so what we're going to do here is just basically distribute the top and the bottom and then see what happens. Alright? So the r1 and the r2, I can leave them alone. Outside over here, r1 over r2. And then I'm going to go ahead and start to distribute. Alright? So distribution on the top, I think it's a little bit long. It's going to be, what is it going to be? is going to be cosine theta 1, cosine theta 2. That's first. And then outer is going to be minus I sine theta 2, cosine theta 1. And then inner is going to be plus I sine theta 1, cosine theta 2. And then last is going to be minus I squared sine theta 1, sine theta 2. Okay? That's for the numerator. And then for the denominator, we're going to do the same thing, just distribute. Okay? If I do that to the denominator, it's going to be the same thing, only that the theta 1s are going to be theta 2s, right? So I can just rewrite the same thing I have on the top, but wherever I have theta 1, I just write theta 2. Okay? If I distribute, it's going to be cosine theta 2, cosine theta 2, minus I sine theta 2, cosine theta 2, plus I sine theta 2, cosine theta 2, minus I square sine theta 2, sine theta 2. Okay? Alright. R1 over R2. Again. And then for the top, what we're going to have on the top? For the top, we're going to have, let's bring the cosines together. We're going to have cosine theta 1, cosine theta 2. And then see it's I squared. Remember, I squared is negative 1, right? So I squared and negative 1, this is going to be a plus sine theta 1, sine theta 2. Alright? And then minus, actually, I'm going to switch it around. Let's write this one down first. Plus I, and then I'm going to have the sine theta 1, sine theta 2. And then I'm going to write this one, minus sine theta 2, cosine theta 1. The reason there's no I here is because I already factored these two i's out. I factored these two i's out and then switched the order of these two to become like this. Alright? And then for the denominator, let's see. Cosine theta 2 and cosine theta 2 are identical, so that's just cosine, or wrong color. It's going to be cosine squared theta 2, cosine squared theta 2. These two are opposites, so they cancel out. And then this one is going to be I squared makes this a plus sine squared theta 2. Like that. Yeah. Okay? Now, if we look at identities, when you have cosine, cosine, sine, and a plus, what identity is that? Let's see. Cosine, cosine, sine, and a plus is a difference identities for cosine. And then when you have sine, cosine, and a minus, that's also a difference identity for sine. So what we're looking at here is the difference identity for sine and cosine on the numerator. Okay? Let's see if I can get back to where I was. Alright, so this one is a difference identity for cosine. This is also a difference identity for sine. So we're going to have R1. Okay, let's make that a bracket. R1 bracket cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2 divided by in the denominator when you have cosine squared and sine squared, remember what that is? That's just 1, right? So R2, this whole thing just becomes 1, so I don't have to put anything there. So that's basically the answer that we have. Alright, so that's exactly what I learned. So this whole can become 1. So, yeah, even this long division thing, we don't have to make it that long. We can make it short if I want it, because this whole denominator becomes 1. So that's it. So we're done, basically. Okay? But let me, if you wanted me to add the additional step, you can do that too, but this is good enough. Alright, with that in mind, we're going to try an example with this result. Okay? Alright, example number 2. Example 2, write this down. Example 2. Find the quotient. Find the quotient of 4 cosine pi over 3 plus I sine pi over 3 and 2 cosine pi over 6 plus I sine pi over 6. Express your answer in rectangular form. Express your answer in rectangular form. Okay? Alright, so let's do this. So we're gonna have, we're gonna use a formula. The formula tells us that we have two complex numbers. When you take in the quotient, you divide the radii, or the absolute value. So we're gonna do 4 divided by 2, because this is R1 and this is R2. You do R1 over R2 times cosine of the difference of the angles. Alright, the first one minus the second one plus I sine the first angle again minus the second angle. Pi over 3 minus pi over 6. Like that. Alright? Alright, so let's evaluate the difference. So we're gonna have, well, let's do the difference on the side here so we don't have too many steps. So pi over 3 minus pi over 6. The LCD is 6, right? So what is the LCD of 3 and 6? 6, so I times this by 2 top and bottom. So I'm going to have 2 pi over 3, pi over 6 minus pi over 6, which is basically pi over 6. Alright, so that's what's going to go in the angles. So I'm going to have 2 times cosine pi over 6 plus I sine pi over 6. This is your answer in polar form. Okay? Polar form. But the question asks for your answer in rectangular form. So in rectangular form, all we just need is to find the cosine and sine of pi over 6 and then distribute 2 to both of them. Pi over 6 in your unit circle is 30 degrees. Pi over 6 is going to be it's 3 over 2. Oh, wait a minute. It's going to be, let's see if I can remember it. At the unit circle, pi over 6 is root 3 over 2 and 1 half. That was correct. So it's going to be root 3 over 2 and 1 half on the unit circle. Uh-oh. What did I hit? So it's root 3 over 2 and 1 half over 2 comma 1 half. So that's what we're going to put. Remember, this is a cosine and this is a sine. So if I plug them here, I'm going to have 2 cosine pi over 6 is the x coordinate, root 3 over 2, plus sine pi over 6 is 1 half I. And then I distribute the 2 to both of them. So I'm going to have 2 root 3 over 2 plus 2 over 2i. If I simplify that, this and this cancel out. I have root 3 plus 2 over 2 is 1 plus 1i, which is the same thing as root 3 plus I. Alright? You don't have to put the 1 there, it's unnecessary. This is your answer in rectangle. Okay? Alright, so that's that for the notes for today. Remember, these videos are uploaded on YouTube. Thanks for viewing, and you can access it for your free pleasure.